In the first video, we have discussed about the pK value of water, aldehyde, and the first step is involving an enolization. This is due to the fact that the carbonyl carbon having a lesser, more bond energy, and that's why OH is having this acid-base reaction. There is an enolization, and the enol is not at all forming in a good amount because the equilibrium is backward. This is all about the first step. Now, OH minus is not at all a good base to deprotonate all the aldehydes. So if you have 100 aldehydes, OH minus will just deprotonate 10 aldehydes to form the nucleophilic enolate 3b. This nucleophilic enolate now are surrounded by lots of mother molecules, that is the acetaldehyde. This nucleophilic enolate can attack any of the acetaldehyde molecule to carry on this reaction. Nucleophilic enolate undergoes a subsequent attack. There is a attack, you can see this attack. So there is a attack by the CH2 minus, obviously, and in the step 2 that is a equilibrium step, nor backward nor forward. So obviously it is forming equal amount. There is nothing in respect to that. So we are getting this alpha beta bond. You can look onto this. This is the new bond. And then again, this is the anion of the beta hydroxycarbonyl compound. There is again a protonation on the anion from the water, that is number 4, from this water, and the OH minus is regenerated, and we are getting the beta hydroxycarbonyl compound. So this is all about the mechanism of aldol reaction. You can look, step 1 was backward, step 2 was equal, step 3 it is moving forward. The step 3 forward is such that it can pull the whole reaction forward, because when if you imagine like this, like 100 molecules, 10 molecules goes to this nucleophilic enolate, 10 molecules attack over this 10 molecules of acetaldehyde, so 80 molecules are left behind. So so we are getting 20 molecules of this beta hydroxycarbonyl compound. 20 molecules are forming beta hydroxycarbonyl compound. Then again this OH minus is regenerated. Again this OH minus will attack over this rest of the 80 molecules. Again and again this reaction will go on. There is a fate for this particular way, and obviously we are getting the product. This is the base catalyzed aldol reaction. So let us study about this substance that I have written. In first step, acid-base reaction forms the nucleophilic enolate 3b, that is 3b, by the abstraction of alpha hydrogen atom, the alpha hydrogen atom 1 of 1, this is of 1, that is the acetaldehyde. The second step involves the subsequent attack on the electrophilic carbonyl compound or electrophilic carbonyl group of 1, this one, by the enolate 3b. This attack about this step 2 forms the alkoxide 5. This is the alkoxide 5, which in the last step hydrates to the hydroxyaldehyde 6. Thus the hydroxide is a catalyst which is regenerated again. Thus this is the base catalyzed aldol condensation enolate mechanism. This is also called the enolate mechanism. So thank you. We're going to study the next one in the next video.